Thank you, Dr. Tongzen, Dr. Leon, and thank you for the viewers. I think this is a timely conference, Emerging Trends in Engineering and Technology, and I'm grateful for the opportunity to share some of the techniques and strategies being used today in the field of transportation engineering, as well as the application of state-of-the-art software, as will be shown in this project. So it's towards an optimal road access. So we're looking at the UWI South Gate. And for those who pass anywhere near that area, I'm pointing, this is the gate. Here, this is the highway, Churchill-Roosevelt Highway, College Road, into UWI, Watt Street, the engineering department right on the edge here, some greenery, the guard booth somewhere here, this is this point here, I'm pointing, car park here and car park, the engineering car park here. So we all have an idea. This has been, the problem here is this gate here has been subjected to traffic for many, many, many years. So try to do a little something on it. So the criteria, including the constraints, are as follows. You have a university, an urban university, and its presence and visibility is mixed up with a little local road called Watt Street. That is the priority road in that area. Typically, in terms of transportation planning, you should have through traffic diverted away from the area of this prestigious institution. Complex intersections should be avoided, and the land and development and street development should not break up the campus into pieces through the activities performed by these local roads. The Transportation Handbook says that major arterials here should direct traffic directly to the campus, and streets not destined for the campus should be accommodated elsewhere. We note part of the constraint, the extremely close proximity of the University Drive to Watt Street. Some of the buildings, engineering buildings, for example, they are very near to the University Drive. And the layout configuration of the road entry and exit makes any improvement very difficult. Perhaps that is why this has been overlooked for some time. And it's located just about 180 meters from the main arterial, the Churchill-Roosevelt Highway. Right, so in terms of analysis, we have the level of service, which is a qualitative measure, and we focus for intersections, we focus on what we call control delay, the number of seconds per vehicle taken at the approach to the intersection. So A being the highest quality, F being the lowest quality. And in urban areas, level of service D is acceptable, that's here, and for other areas, C. So we collected in November, pre-COVID period, we collected 24-hour traffic data, and as everyone knows, morning and afternoon peak hours are the highest. We use for the intersection analysis software known as SIDRA. I know the university uses it as well, and it's internationally one of the best intersection analysis software. So we applied this to the project, and we found this. Watt Street, as expected, the local road with the priority level, quite a high level of service. This is in the AM peak hour, and the approach from the highway, level of service, the F, the lowest, and of course coming out of the university, not as bad in the morning, as you will expect. There are very few people coming out from the university in the morning, but the highest volume, and the evening period is very similar. but because of time, we just showed this one. So what to do? So how do you take all those constraints and try to come up with some type of improvement to access in and out of the university, as well as facilitate the other roads? So the authorities do not prefer to change priority from Watt Street to the North-South College Road. So that's out of the question. You have the buildings nearby. You have the near road, the University Drive, right on the edge of Watt Street. You have the surrounding parking areas. You wouldn't want to reduce too much of the parking facilities there, at least at this stage, and the greenery and so on you want to minimize, and yet create a priority for this prestigious institution. Well, we looked at what we call a double lane roundabout, and a roundabout is designed with the following features. Entry radius, which is right here, the curve of the approach to the roundabout. Inscribed circle, which is the diameter, inscribed circle diameter, which includes the circle plus the lanes. So this is the inscribed circle diameter. The entry width, which is this width here, the perpendicular distance here, that's the entry width. And of course, the circulating roadway width. So this is called a double lane roundabout because it has two lanes. So we are proposing two roundabouts, as we'll see, one outside the campus and one inside the campus to handle the security. If you get turned around and you can't continue, we'll see it in the drawing. So the parameters we use to try to fit everything with regard to the constraints were as follows. This is the diameter, the central island, and so forth, the inscribed circle, the entry radius, the entry angle as well, which is the angle between the circulating roadway and the entry, and the entry lanes, the average entry width, and so on. So these are the parameters. And we also use another software called AIMSUN for microsimulation. So you have software for traffic analysis, and now we are using one that is simulating continuously the activity on the roadway and presenting it either in real time, which can be done, but not here, and you can present a picture of what happens. We also projected it for 10 years using a 2% non-site growth rate as shown here. And we found that the results were quite good. What we are looking for in this case, as we look for level of service in the first one, we are looking for VC ratio, which is the volume capacity ratio, which is the number of vehicles divided by the maximum number of vehicles passing a point. And the results for the existing period as follows. This is the legend here. The darker the color, the worse the traffic. You see entering the university, and this is Watt Street here. This is the new configuration of the double lane roundabout. And we created, this is the University Drive here, and we created just near in front of the JFK Hall, for those of you who know the campus, that open park, yes, it'll be lost, a single lane roundabout to cater for those who have to get east and west internally on campus, as well as those who, when processed, found that they're not acceptable on the campus, they make the route out. And this is it. And this is it here. So, in conclusion, a double lane roundabout was shown to work very well for at least up to 10 years. And it includes a smaller single lane roundabout to cater for those who have to go east and west, as well as to process visitors who are both welcome and unwelcome to the campus. Thank you very much.
Thank you very much, Dr. Furlonge. Dr. Leon, do you have any questions on the chat?
Oh, no questions in the chat. Yes, I have one question now. It's actually a comment, not a question. Okay, one second. Questions are coming in now. Was the impact of the security considered?
Yes, the security, that's why we talk about the processing, and that's why we put the second roundabout, apart from moving east to west, for processing. So the booth would move about 20 meters further to the north to cater for the processing and send them around if not welcome on campus, or direct them to east or west where to go. Yes, so the answer is yes.
Next question. You suggested an optimal solution. Did you also take into consideration the universities all over the world become test beds for sustainable solution, with simulating less car traffic and encouraging other models? I guess it's a comment, not really a
No,
question.
the question is stimulating less car traffic and encouraging other modes as opposed to an optimal traffic solution.
Well, very good. When our level of thinking in this country goes in direction, that's a policy approach. When we become sustainability thinking in transportation and we are not car oriented, yes, it will be good to reorient the approach to analysis towards that. The campus, as you know, is still free parking on campus. So the policy on campus is just as bad. If you were to take up those policies and reduce the number of vehicles on campus, as done in the foreign universities, as identified by the person, yes, those things can be taken into consideration.
We have another question. Was a minimum roundabout also considered inside the campus in an effort to reduce the reduction in green space?
No, if you understand what a mini roundabout is a roundabout that fits into the existing roadway configuration. Can you imagine how that will work at that intersection? In other words, a mini roundabout has a radius, a diameter of the order of about 4 meters, 5 meters to fit within that existing roadway. Unfortunately, it will not be able to handle the turn-in movements required.
And I believe another question, were the queue lengths measured?
Queue lengths are all factors in the level of service. I emphasize control delay. Queue lengths generally feature more on mid-blocks and highway and on the length of the highway. They very seldom feature for the analysis of the intersection itself.
Okay, thank you. And one last question, final question. In the PM peak, the traffic from what street prevents UWI traffic exiting? A roundabout will not solve that. How is that dealt with in this design?
Let me hear that again, and you kind of broke up there a little bit.
In the PM peak, the traffic from what street prevents UWI traffic exiting? A roundabout will not solve that. How is that dealt with in this design?
Well, actually, a roundabout solves it better than it does now, because all the traffic will be circulated and priority will shift from what street as it is now to everybody waiting on the vehicle that is already in the section. That's how a roundabout works. You give way to the vehicle that is already circulating and you enter. It's not necessary to stop at a roundabout, as you have to stop at a traffic light or a major stop, a minor stop. A roundabout, you give way unless nothing is passing, then you enter. So it may not be necessary to stop, provided side distance is clear, so it will function actually even better.
Well, thank you for your answers to the questions. Dr. Thompson, that's it there.
And thank you very much, Dr. Furlonge, for that well-researched presentation and for answering our questions. As you can see, generated a lot of questions, and I'm sure that you can email or further questions to Dr. Furlonge, who'll be glad to answer